Thank you very much. This is the last session of the day, so we have a few more people still kind of getting their tea and coffees in. But so as she described, on my right is Mr. Kapil Sharma. So you're here for the Kapil Sharma show. If you think you're going to hear about steel design, you're in the wrong conference here right now. No, don't laugh that much. That's okay. So nonetheless, so the topic of discussion today is how technology is transforming the design and construction of steel. So I did talk a little bit about that in the morning session, but we're also going to include the construction aspect of that today. And as was described, I think on my right-hand side, we have two really great engineers, and on my left-hand side, we have two architects. And so I'm going to be moderator, trying to kind of hold the peace in between these two groups here. But the point being, I guess we all need to work together to kind of deliver projects and see how technology has been changing how we deliver projects and also kind of as related to steel design. So as we've kind of started to look into how it is changing, why don't we first step back and see before there was much use of technology, maybe 5 years, even just 5 years down the line. And if each one of you can describe what is it that you guys were doing differently before we go there. So we'll start from there and then go all the way through what the next steps are. So anybody can go first. You wanna go ahead and get started? Well, let Kapil go. Yeah.
Hello? Hello? Yeah. So if I talk about 5 to 7 years back, so the major change what I see is migrating from 2D to 3D. 5 to 7 years back, everything was in 2D. The clash detection was a major problem. Because of that, a lot of rework, quality related issues, productivity related issues, and projects were getting delayed. This is one thing. And second thing, what I have seen that the factory mode or modularization is a lot, or maybe not a lot, but definitely we have gained pace. 5, 7 years back, everything cast in situ, whether concrete or steel. So these two things I feel we have improved if I compare with 5 years.
Okay.
Good afternoon. Yeah, it's slightly tricky for me because I come from a different experience of working in the UK and in many parts of the world. And
can you hold the mic a little closer?
And I think this transition began a lot earlier. I was using 3D printers in the late 90s, 25 years ago. We did BIM on a museum I designed in 2002. We in Arup in London sort of had policy that everything is done in 3D 20 years ago. Yeah. And so I can give a perspective on, I wouldn't say I can give a perspective on where you're heading because the technology has moved as well. So what I was doing, it's not that what I was doing 20 years ago is what you're doing now. It's just that this transition to new technologies happened a long time ago, began a long time ago. And so what does it result in? It might be the interesting thing from our perspective. It clearly does have what they all promise you, what Autodesk promises you, what these people promises you, that you have a better coordination, fewer RFIs. That's definitely true, and you'll see that. Does it make the design teams work better together? Question mark. Not so sure. Because sometimes they think, because we've swapped models, that means we've worked together. Whereas the other way of working together is to sit around the table. So simply swapping models isn't really collaboration. It's not quite the same. So I don't think it's succeeded. You have to be careful to not lose the human contact in collaborations. And collaborations between architects and engineers and clients is really the method of creating great design. It's only through that true collaboration and true interest in each other's realm. Be nosy. So if I'm a structural engineer, that doesn't mean I don't question the architect about what they're doing, and I don't expect the architect just to believe me as a structural engineer. They want to try and understand and question.
Yep.
So collaboration is sticking your, there's no such thing as your silo. There is legally and delivery-wise and responsibility-wise, but in terms of actual day-to-day working, you want to make architectural suggestions, and I want my architects to make structural suggestions.
Yeah.
And ideas. So anyway, I'm not really answering the question other than to say that it's an interesting journey. This change simply from 2D to 3D, but of course it's much more than that. It's from data. It's from lines on a bit of paper or even lines in a dumb model to intelligent objects.
Yeah.
And trackable intelligent objects. Yeah. And of course the promise of this world where you use that model all the way through to, it is basically your facilities management.
Right.
It's everything. And of course, in many of our clients, especially the big corporate and government clients, it's absolutely demanded.
Yep.
You've got no choice.
Right. So no, thanks for sharing that perspective. I think, like you said, I think what KAPIL started doing maybe 7 years ago, you've been doing for maybe 20 years. Same thing for us in the US. We probably switched to BIM 20 years ago. And what you talked about integration, I think, and working collaboratively with the architects is absolutely important. And we'll get into that. Siddharth, you want to answer the same question? What do you see yourself doing differently?
I think one of the first observations I have is in terms of design as a very linear process. I think technology integration has started challenging that to a large extent. I feel that we are now able to design in a sort of non-linear manner. Yeah. Certain parameters that were sort of the way we designed previously, those are no longer applicable. We can work across geographies, we can work in different software. People don't need to sort of wait for stages for the right inputs. We are able to sort of get faster turnaround times for our clients. Yeah. Sort of integrate, whether it's engineering solutions or whether it's costing. Technology is able to answer a lot of those questions faster, which means that the client expectations have increased. They're sort of expecting things faster. Yeah. It's a challenge, but architects have to sort of keep up. One of the other things that we see is that the whole idea of working in silos is now gone away. Yeah. COVID taught us that. So during large parts of COVID, we were actually working on a project in Hong Kong where it's the largest project ever done on Revit in BIM. It's 150 people on a single BIM 360 model working across, across boundaries. And what it does is that this whole idea about a single architect in control and sort of guiding things as opposed to multiple people chipping away at multiple things. It sort of decentralized the whole notion of architecture, which is being centrally controlled in one place. Now, whether that's a good thing or a bad thing, but what it does is it does allow you, after a design's frozen, to come into and take up smaller components. And in a way, what that does is it allows you to sort of work in a more focused manner and be able to sort of manage larger teams across different geographies.
No, that's a great viewpoint. You said 150 people working in the same model. You're right. I'm not sure whether it's a good thing or bad thing, but that's for a debate for another day. However, what it shows is technology has come a long way where you can do that. I remember probably not even 15 to 20 years ago when I was working on a big project, a stadium project, we had to wake up in the middle of the night just to hit the button so that it kind of runs all throughout the night, and by morning when you wake up, at least one of those designs is done for a big truss. Yeah. From there to now where we are doing thousands of models in a day easily, or not easily, I guess I would say, but we have that opportunity, something that like that can be done. So technology has evolved quite a bit as well.
Gives us an option.
Gives us an option, yeah. SEEJA, anything you want to add other than what these guys have already said?
Yeah. It's much less relevant to me, but yeah, I would still add on to it that I've seen one big shift, especially post-COVID in the last 4 years probably, is the adaptability of newer technologies. As far as the client perspective goes, earlier when we used to speak about things, there was a lot of friction as to why we should do something. But this kind of shift in like living itself has made such a change that people have become much more adaptable about it. There is a lot of acceptance to newer technologies, newer ideas, and that's made a lot of young architects very relevant today. Because when you go up to somebody with an extremely different idea, they are not really standing there to just strike it off. They are very open to the idea. Of course, it has to be feasible. You can't go above budgets, you can't go above time, but then ultimately there is an open discussion about a newer thing. So that's something that's been a very big shift. I think ever since we are working, we've been working on 3D models and things like that. So that's not something that, you know, we have faced. But again, even in that, the cross-compatibility between the different softwares that we use, like even if we are using parametric softwares for certain parts of it, at least in India, the projects don't go such that the entire project can be done with that. So we always had to integrate different softwares with BIM and parametricism and then take it to another level. So that's again something that's helped us a lot, even with the structural engineers that we work with.
Yeah. So no, that brings a good point. And another thing that I was, well, let me go back to something else first. So we kind of all talked about it. One of the change that you mentioned is kind of going from this 2D to 3D. And we kind of expect that a lot of these cases that BIM or building information modeling in 3D is kind of table stakes, right? I mean, that's something that has to be done. But is it really the case in India, and are there any challenges that you're seeing when you're working with your project delivery partners, with your consultants or with your architects? Is everybody really in 3D? I mean, let's just start there at the basic before we go into connected models and what you got into. So what do you think? I mean, when you are working on projects or when you're working in the Indian environment, is everybody really BIM ready? Or what are the challenges that you guys are seeing?
So I would answer, it's like at a 50% currently. At least in my practice, I haven't seen more than that. It's some of the engineers with us are very open for BIM modeling, but most of the times there are situations where we actually have to remove it from an intelligent software, put it onto a dumb software, and then, you know, pass along the drawings. So that's been a challenge because of non-adaptability, but it's rapidly changing. Like I said, post-COVID especially, it's rapidly changing. Today, it's much lesser than what it was 5 years back.
Yeah, good. No, I think, I mean, it's kind of surprising where a lot of the 3D visualization back-end work all around the world is being done in India. However, on Indian projects, Indian consultants, they're kind of not as fast as adapting. Any other challenges that you guys have seen with adaptation of something that we consider so basic as BIM?
I think one of the first and foremost things I've seen is I fundamentally, at least in our organization, while we propagate the use of BIM, the first question is why BIM, and why exactly are we working on BIM? Did the client need it? Are we doing it for our own ease of comfort? Yeah. Those are questions that we should fundamentally be asking. Most of the clients want faster turnarounds. Actually, half of them don't care about BIM. But the thing is, if it aids our project workflow, our typology of work, we absolutely do engage in it. But then begs the larger question, what exactly are we using the BIM model towards? Are we using it for fabrication? Are we using it for internal coordination? And on the basis of that, we sort of decide, okay, fine, you know, do we go to what LOD level and stuff? But I guess there needs to be a larger conversation, and the onus is upon us as architects to sort of engage with our clients a lot more actively and proactively and convince them that, you know, BIM is the future and it'll help in different stages of projects, right from setting up the projects to site accuracy, level coordinates, right up to fabrication, the end-to-end. And, you know, it's getting better, but based on our experience, a lot of clients are reluctant because they see that as an added layer of complexity that doesn't really solve their problems.
So why would clients worry about it? I mean, is it because of the fee that it would change? I mean, why would they bother? If you're doing something which is a better product, it's easier for them to visualize at the end of the day, if it's much more coordinated project, why do you think that they are reluctant in adapting that?
I think it's a lot to do with what they understand. They have own in-house teams as well. And a lot of times that means that upskilling the entire ecosystem. So you encounter one little obstacle and then the whole BIM workflow sort of, gets stuck at one point. In some clients, they're very sorted. They have a complete entire BIM team. So, everyone's on the same page. We're talking the same language. Yeah. But in a lot of cases, you can sense that reluctance. But some of the contractors, they're directly taking BIM models into fabrication, which is fantastic. Yeah. And I think the future is only bright as far as India is concerned.
So we'll get into level of detail or something like that. But Kapil, what I want to ask you is, these guys talked about from architectural and engineering standpoint. But when you're seeing on your projects and when you're doing project management, are contractors actually using that? What challenges do you see happening in that?
So, Abhijit, if I talk about from construction point of view, BIM is an ecosystem, what I take it. In an ecosystem, all the stakeholders should have understanding and capability to use that particular technology, whether to talk about it, SIDDHARTH said, clients. So both the issues are there. One is the schedule challenges because they want to hit ground maybe in first 3 months, which is not possible if you're going for a full model. The second thing is cost is also, but I feel cost is again a secondary part. The first part is the schedule challenge. The contractor ecosystem is where we need to improve a lot in India because we are developing a model in BIM and then we are providing the 2D drawings to them because they can't work on a BIM model. They are submitting their shop drawings, they're sectioned into 2D and then consultant is developing. So clash detection at site level is very, very difficult still.
Yeah, so exactly what she said, that you have to dumb down the models for the contractor to see. At the other end of the spectrum though, we see some contractors who are kind of trying to push it, and maybe not as much in India, where if the architect and the engineers are not providing a BIM model, they hire their own consultants and kind of do that so that they can do the clash detection. So people or contractors who see the value, they're definitely doing that. So I think as in any change, I think there's two ends of the spectrum, people who don't want to change and people who are kind of at the leading edge. And Francis, you said, I think as one of the challenge or something you already mentioned that, don't think that because you're exchanging models means you are collaborating. You still need to get together and kind of talk about things. Well, that can be done virtually as well, but that needs to happen. It's not either or. I think you still need to all work together in an integrated fashion, right?
Yeah, two quick points. The point about in early days of BIM adoption, the most successful, in consultancies, there was a lot of the questioning of why this is more difficult. Why are we doing something in complicated 3D when I can describe it in 2D? Why are we bothering? But as you say, where it first got adopted, in my experience, was on jobs which are good for construction. The contractor's taking over. There's no more design changes, so there's no staging, and the contractor wants to have control. So the first job I remember having a full BIM model on wasn't by the consultant. It was after we'd finished the entire design.
Contractor.
And thousands of drawings. The contractor put a fantastic BIM model together. They also did it in weeks.
Yep.
Because when you're not changing anything, it's easy.
Yeah.
And then they suddenly had a complete virtual model of the building. And I thought, this is wow, this is interesting to do it at that stage. And then everybody tells us, oh, we should do it from the earliest stage, which of course is much more difficult because you're constraining me. I don't want to decide now whether that's 3 millimeters or 10, or that kind of stuff. That's one little interesting thing. So I think you will find contractors, it's very positive if contractors are saying they want the BIM model because that means they're taking their role of packaging and building everything seriously, and they want to coordinate everything.
And because
before they spend money making
exactly things. Because they don't want to do the mistakes, and they don't want to, because they are the ones who are kind of spending the money. Maybe it's owner's money, but somehow it's all related.
But on another level, I have white beard, and I am a skeptic. I can be Luddite and skeptical, and it's partly because maybe it's my background. I used to be a mathematician. I want definition of building, setting out and definition, and everything from the architect's vision through to setting out of everything to be a very logical and rational and thorough system. When you're doing everything in models, rather than saying, this is my grid system, offset that so much this way, offset that so much this way, it's a set of rules. If you're just building it in 3D, you can be slapdash, and we've seen that. So many 3D models of every type done by people who are not of that mind of, they just want something that looks right quickly, and they don't know the tool very well. They are slapdash. And so you end up with models which are really annoying for engineers, really annoying for someone who actually wants to build it. So at one level, I like the idea of describing everything geometrically by a set of rules, and I can write those rules down on a bit of paper.
Yep.
And yes, I follow those rules through, or now in a Grasshopper script or something.
Right.
But the point is, it's a set of rational rules that gets me the result of this curved roof. But it's not just a curved roof. It's a curved roof, and it's made by this method. And that method is the definition. I tell the contractor, that's the definition. Don't take my BIM model seriously. That's the definition. Make it again yourself. Make it yourself. That's the best way to check that someone has understood something. Rebuild the model from scratch. And that's counter to a lot of the philosophy.
Right.
But at least rebuild it to try, so make sure you understand.
Absolutely.
You don't have to rebuild the whole thing. You can, once you've rebuilt, try a little bit. You follow the rules. I did this offset, that offset, spherical here, this, that. I got the answer. Just try, just so that you get some confidence.
Yeah.
Because for me, I want to have a rational building. A rational building doesn't mean, well, I mean, I also want to have as simple as possible, but you can often ask, why are we making things more complicated than they need to be? And that's an interesting question for someone who wants to be, if you're a freeform artist, you don't ask that question because you're saying it's visual, but in a building, I don't know, instinct is, the older I've got, the instinct to go simple has got stronger and stronger and stronger.
Yeah, no, I think you definitely bring the other end of the spectrum, if you will. But no, I think so. I don't think we're suggesting that we kind of do things just for the sake of it, or do it in absence of any realistic boundaries. So we need to kind of have both those things. There has to be a balance. I mean, not just do crazy things because they're possible in a Grasshopper or some parametric model. A tool can do it. I mean, there has to be a reason why you're doing that. And at the end of the day, we need to understand that these are tools at our disposal, and they are not the ones creating the model. So that's, I think, the basic difference that we need. I mean, all of us design professionals need to understand, right? I mean, the attitude that we take. So it's not just doing cool stuff for the sake of doing it, but yeah.
So just one second. Why do you do it? The reason you should do it is because it should be somehow linked to the material or manufacturing process of what you're making. It's
Sure.
not done for the metaverse to look good on the internet. It's done so you create, for example, and Frank Gehry's team was doing this years ago. You
Yeah.
create straight line, and Gaudi was doing it.
Yeah.
You create straight line generated surfaces. And the reason you create straight line generated geometries is because that's linked to a method of making, manufacturing.
Sure.
So if every one of your geometric choices and your design decisions is linked to the material and system of manufacture and factory, that you'll end up with interesting buildings, because nature doesn't create cubes.
Right.
Nature creates interesting curved shapes.
Sure.
And that's because physics wants to do that. And
Yeah.
so, but don't do it just because it looks like physics. Do it because you understand
Why it needs to be
does
done.
that.
Yeah. And it could be for simple structure. As an example, for a project that we worked with SIDDHARTH on, I mean, it could be a simple thing as a truss that needs to be designed, but there needs to be some parameters set to it because there could be sightline issues happening, At the same time, you need to figure out what is the most optimal structure. You need to satisfy what the architect wants from a sightline standpoint. You need to satisfy kind of a sustainability goals that all of us should have, that we are not kind of wasteful of the material. So we need to use the least amount of material. And if I just kind of try and do that by hand over and over again, it's going to take me a long time. So in that case, why not use a parametric model to come up with the best solution? What is the best shape of this truss which can be kind of designed, which follows all the parameters that are set. So there's nothing to do with curves, but very simple things. And that's what I mean by when saying use it as a tool to solve a problem rather than using it to kind of design, do design by itself, right? I think it should be on.
Yeah, I think that's a great point. In fact, the whole idea of manufacturing the process, and it's not just a one-way communication. I think it has to be, we have to take the inputs back from what the market tells us.
Right.
I remember the project that we worked on together. It is, we responded to the local market of Chennai. We went back to the fabricators and the manufacturers, understood what their constraints are, came back, remodeled the entire facade geometry to allow them to and incorporate the local constraints. Conventionally, that would have taken us weeks. We were able to achieve this outcome along with an entire documentation package in a matter of days. And that whole idea of that feedback system, I think we should be doing it more actively. Get the entire end-to-end supply chain, including manufacturing, erection sort of constraints incorporated into our workflow, whether that's BIM or however we go about it. Another factor that I would love to personally see is the whole idea of embodied carbon and that information being available at through the, that's why the BIM, I think the whole idea of that information, I feel that eye right now is a little limited in that sense. We haven't really achieved the full potential of what that eye can offer.
Sure.
And that's something that personally interests me because the buildings that we do are massive in footprint, and small decisions can really take have huge cost ramifications, or energy efficiency issues can come in. So that's something that I'm personally interested in seeing how we can sort of integrate the sustainability in the eye.
Okay, no, so since you have started this discussion, let me ask that question. So are we actually using this technology and are we leveraging that to kind of attain our sustainability goals? I mean, as we all know, I mean, the construction industry, all of us sitting here, we produce, and then it could range from different calculations, anywhere from 30 to 40% or maybe even higher. We contribute that much to the greenhouse gases. So I mean, it's all our responsibility to make sure that we are doing a much better job in kind of reducing that. And are we using the technology, maybe it's BIM or there's other things, but are we using that to kind of leverage these technologies to minimize the impact that our industry is creating? Any thoughts? You want to start with SEEJA?
Yeah, so I agree with the nature bit, what Francis spoke about earlier, that so when we look at systems in nature, it's usually we use the word systems because they all work as one. So it's very cohesive. It's not one hero element, there's no columns and there's no beams, and it's all quite supporting each other. So this whole elimination of hero systems from construction is very important, even if we want to go towards a step of sustainability.
Right.
And secondly, these crazy forms, like you said, it shouldn't be crazy, but how do you define that? So that's something that has been such a problem, right? Because one man's crazy is others like complete sensible thing. So it's a very nuanced line to cross. So you need to know who your client is, what will he consider crazy, what won't he, and what will fit on the site context and what is supposed to be done. So this newness of architecture is creating a lot of chaos. But I think in India, it's also the chaos that's coming just for us to achieve kind of an equilibrium where people understand what's happening. So just before we kind of settle down, we have a lot of ups and downs. So we are right now there. So it needs to kind of settle down before that. So, but otherwise, yeah, so natural systems is something that we should all be looking at. And like he said, Gaudi's structures and how he's used catenary curves, which is something very stable. And the arches that he uses is something very stable. So those forms are again working as a system. They're not working as isolated things wherein, we break down the brick wall and the column still stands. So it's not working like that. It works more of a system. So that's something that should be looked at as far as construction goes.
Yeah, biomimicry and how.
Yeah, biomimicry informs. It's a very loosely used word, and I'm
Right.
also like at this forum using it extremely loosely, but it's very deep. You can go really deep into it to understand how natural systems work. Because you know, like to get like we always say, to get like this complex shape of birds, a school of birds flying, where you see this amazing shape that's coming. Actually, the system is very simple. Each bird is just speaking to the 6 birds around it.
Right.
But then that kind of system, which is extremely simple, can manifest into something very complex. So that is something that we should always look at. Like our modules that we are creating for a facade as well, everything doesn't need to speak to each other. It's just adjacencies that can create something really complex.
Yeah.
Even if we make complexity for the sake of it, it can still be simple.
Yeah. All right, you guys want to add something on the sustainability point and how technology should and can be used to make things better?
So Abhijit, to answer your question, I think we are using technology from sustainability point of view in a very, very small manner. What can it be? For example, if we can do factory mode, but factory mode needs scale, means technology needs scale if you want to do something maybe more environmental friendly and more cheaper in terms of cost also. For that you need standardization. I did 1 or 2 projects in Europe, so there are standards for even windows and doors. You are not open to choose anything in your buildings. So scale is important for technology, which we need to create as a player of this particular sector. The second thing what I wanted to say in sustainability, we are creating buildings which are good, but again, on the BIM side, we are still discussing on 3D, what about 4D, 5D, and then 6D. So 6D about energy conservation, how you simulate, how you use, or maybe long-term energy efficiency of that particular building, still we are far off that level.
Yeah, unfortunately, we don't have a mechanical engineer on the panel here, but I think, yeah, anybody's free to comment. I think from a structural engineering standpoint, at least, I think, the better models that we have, we can track the quantities better. Not only just concrete versus steel, but different grades of concrete, different components of steel, the decks, the columns, that, different shapes. And if we can feed in the embodied carbon kind of information, then I think it's very easy to make those decisions which are not just based on aesthetics or engineering, but kind of something bigger, where not only the design team, but the owner can also contribute that this is what my goal is, and things like that. And you said, from a MEP standpoint, I think building these models, model twins, and see how those kind of behave, how the least energy can be kind of used, not only during construction, but throughout the life of the building. I think those are the things which we should, and I know we are kind of using these technologies for benefiting the project. Francis, you want to add anything to that before we move on?
Possibly not. Less is more, and so if you're building less layers and less things, then you should save money and you should save carbon. Of course, what we all need, and I don't know how fast it's going to come, is a correlation between cost and carbon. Because having these 2 different kind of costs is very tricky to maneuver.
Right.
Okay? If you have a more expensive scheme that's lower carbon, what are you supposed to do? You tell the client, and the client says, well, I can't afford that. Okay? But really, there needs to be political will and methods for basically paying for the pollution that you create. So if you're creating something that has a lot of carbon, you have to pay for that, because somehow it has to be paid for. And so when that happens, I look forward to that day. It'll probably take a decade. It's happening very slowly, not fast enough.
Happening in pockets, though.
It's happening in pockets. And then what the game is what, for me, the structural engineering has always been efficiency.
Yep.
Of course, that doesn't mean you ignore the artistic side of architecture, or you just do something. Of course, there's constraints on that, but what you want to do is make something that's not wasteful, and money-wise or carbon-wise. And yeah.
Okay. All right, I'm gonna.
Sorry, Abhijit,
No,
sir.
go ahead, go ahead.
On your last question, sir, I wanted to add on the ecosystem side. So, for example, in UK, they have made mandatory to use BIM in all public projects. Just make me correct if I'm.
Yeah.
I think this is the right time for Indian authorities also to bring these kind of policies, and this should not be just for the sake that we are just ticking a box and this is even not LOD 200. So minimum LOD 300 or 400 should be mentioned based on the project size, so that we create ecosystem of contractors and consultants who understand and who can work.
That's a good point. Sometimes things need to be forced on everybody for the change to happen. And what you mentioned earlier as well, I remember when we started adopting BIM, the Revit was the software of choice at that time. Initially, people were reluctant. Why do simple things in 3D? And now they don't want to go back to 2D. It takes the same time. It's better. So why not do it is kind of the place that most of us are in right now. And so what you said, Kapil, is right. If there's somebody who pushes it and people see the benefit in it, then I think it will happen.
So just for example, I did a project in 2008, an office building project, and you will not believe we have to cut 600 cores during the installation and finishing phase. So you can understand this doesn't happen now, but in 2008 it was in many projects in India. It was happening.
So cutting 600 cores.
Yes.
Wow. All right, I know we've talked about models quite a bit. One last question on the modeling side, and then we'll switch gears. So currently, we have any given project, there's tons of models happening, right? There's like a parametric model or some designer, maybe it's an architect or engineer, finding form or something, so that's happening on one end. There's an independent model happening on the engineer's office who's doing the engineering model. There's some drafter or some technician who's kind of putting together a Revit model. The steel detailer is maybe probably putting together a Tekla model. And there's been some connectors and interportability and so go from Revit to Tekla, let's say Tekla to Revit. But the time has come where all of these need to come together. So my question is, are your models talking to each other? Is there a way that you guys have seen to connect all these different models? Has there been any movement in that, or what are your thoughts about that? And I'll give my thoughts also.
Sure. So our design workflow, I think we've come a long way in the last 4 or 5 years. Previously, it used to be quite challenging actually, because to rebuild a Revit model, firstly you get the design done in some other software. A lot of people use SketchUp, people prefer Rhino. But Revit used to almost be a start from scratch kind of a scenario. You get the design done in some other software, whereas Revit was pure documentation, and it comes in at a point when a lot of decisions would be taken, and then people used to dabble with AutoCAD in the middle and then finally come to Revit.
Right.
But I think we found a bit of a sweet spot in the way we work, wherein we've got some plugins, and I'm really bad with some of those, the names of some of those animals that come as plugins of Rhino. So we do the modeling in Rhino and directly take the model into Revit now in an editable format, so that none of the nuances of the design and whatever decisions we have taken in the concept design stage, the integrity of the design sort of continues, and then that's sort of seamless for all the different components to start now coming into the model. So there is no abruptness in terms of where concept designs, the stage ends and then schematic starts. It's quite seamless. And we are also working on live models wherein the changes that you make in a Rhino model actually gets plugged into Revit. So that concept design changes can start reflecting in the live BIM 360 model. Those things can actually be viewed by our consultants as we make those changes. So it removes that element of disconnect. Whether it's seamless, not really, but I think it's a lot better than where we were 3 years ago. I still remember, I think one of the initial projects, when we did the Narendra Modi Stadium, that was all done on AutoCAD. And still we could do the repetitive panels and still achieve the same outcome. But spent, gosh, how many weekends, just working, trying to sort of rationalize the panels and the number of cores. But now I think on any one of those similar stadiums, we could do it in a matter of just days. I mean, it's so much easier, and the team also can sort of seamlessly switch. We can churn out more options in a shorter span of time as well.
Right. No, that's a good point. I didn't know you guys did the Modi Stadium in AutoCAD. We had the Revit model. You could have asked. I'm just kidding. No, so that's a good point. I think some of the tools that kind of going from model to model. One of the things that we've done internally, and I know a lot of companies like Arup also have similar things, is where we've kind of have a internal BIM language, if you will. So all the data gets converted into something that we called as a central interportability database. And everything is basically, because everything is data at the end of the day, it's just you need to figure out which software is using that. And so then you're not forced to go from just one place to another, or some other software comes up. And then all this data can be manipulated. And it's not a black box. Everybody in the company has access to that. And it's something that can be used not only to kind of go from one software to the other or something like that, but also kind of looking at different quantities, sustainability of things, and connecting that to Power BI. And so all these kind of things are possible, and I think that's where it is headed. SEEJA, you want to add anything to connectedness of the models? Or?
I think I covered it probably. It's important to take it to BIM at the, so we usually do concept on Rhino and like softwares that you mentioned. And the connectivity is very good now. Like, again, you know, even if you're fabricating something and you understand that the facade has to be X length for the panels to actually be distributed, and you change it in Rhino, it will change there, and vice versa. So it's become very easy that way.
Yeah.
So during the fabrication time also you can make changes, and that's genuinely a great thing. And as far as taking it to always like a BIM software, which is very important, because later on the digital twin can be made for the same. It can be used for management. It can be used for a lot of things. Right. So that's where, you know, you can also connect it to AR, and you can connect it to other things, so that the client, even if it's like a small bungalow that the client is living in, he has a digital twin, he can always understand what's going where. Even if there is some problem with the services, he knows what is to be tackled upon. Correct. So that's the reason why we always have to take it back. But I think it will all come across a little quicker, such that even softwares that are for concept today will start having information modeling inside it. Because today, the concepts of softwares, even though you can do a lot of open coding with the help of Grasshopper and Dynamo in Revit, but ultimately, it needs to have that quantification and information inside, which is still a little missing when it comes to concept softwares.
Yeah. I think you guys want to add, otherwise we'll...
Well, I just point out that, you know, we're typically working as engineering consultants with dozens or hundreds of different architect practice. Architects are the lead consultant on buildings. They all have, even with teams within big architectural firms, have different capabilities and different desires.
Sure.
We have to be flexible. The ideal world you're describing is an architectural practice populace. You have the power to make sure your projects are all super well organized with a central intelligence. And we all know about that theory, but I wouldn't say I've seen it in practice. I've seen it in practice in a few jobs where both the architect and the engineers, they're both enthusiasts, they're setting it up. But to set that up in a firm of 18,000 with hundreds of thousands with so many thousands of jobs and so many different collaborators, it'll come, but it's a very slow process to do that. And all I'd say again is the whole way along is, I know we talk about concept design as if that's concept design's done, now we're going to move forward. Certainly on smaller jobs, even bigger jobs, you know, I don't want to be constrained by that. I don't want the guy to tell me you can't change the shape of the building now.
Yeah.
I want to completely, if it's the right thing to do, completely rechange it.
And that's where the connected models come in place. I mean, if you make those changes in the architectural model, you can easily just kind of go back into the engineering models and make those changes. So I think that's the value I see in having all these models that are connected.
We have something called, there are lots of formalities that big firms like Arup set up, lots of different forms and processes. Whether they're all carried out is questionable, but a digital inception plan is a tool that we've talked about for years. every project as if there's a day one to a project. There usually isn't actually a day one because projects happen in funny ways. But you're supposed to sit down and do your digital inception plan, which is basically deciding all the ways in which you're going to work. Now personally I find that impossible because before I've even got a design, how can I think about how I want to work? I want to let the real constraints of the project, the materials, the system, the location, is it in Afghanistan, is it here? There's 1,000 things that will influence how I want to model it. There is a trend to globalized design, which of course India will become part of. But it's a sad thing. It's a sad thing when you can't tell, when it makes no difference whether you're designing a building for Delhi or for London. This is not good architecture. This is globalized packaging. And we know why do it. We do it because the industry is global. But we want to fight it as well. We want to fight it and have local vernacular. We want to fight it and do things. My favorite contemporary building in India by far is the Lotus Temple in Delhi, where the architect spent 3 years doing research before you started anything. Now, of course, that's not possible commercially. And so commercial projects have to have their own drivers. But I don't want buildings in India to look like buildings in Dubai, which look like buildings in Manhattan, which look like, it's sad. And the technology shouldn't stop that happening, but it's dangerous, the danger that it can.
Yeah, no, you're right. I mean, there's some truth to that. Again, I'll go back to we need to use technology as a tool and not let it drive what we are trying to do. All right, so a little bit of a switch in direction here now. Are our architectural and engineering schools, have they started teaching things differently? I know in one of the session earlier, somebody was mentioning about some architects that they need to start teaching steel design to architects, which they still haven't. So that was sad to hear, but even taking it further, from a technology standpoint, have our schools started to teach things differently? And these different things, are they still teaching AutoCAD? I know the answer to that, but wanted to have a discussion on that.
So for the bachelor's degree, I'll just speak about architects. I'm not aware of the engineering spectrum, but it's changed quite a bit. I remember when we used to study, it used to be all hand-drawn sheets and things like that. They still do that, and I think that's important because otherwise you don't understand scales when you work with an endless sheet which never ends, so you just don't get scales later on in life. But people are open to more softwares, and that kind of helps the students be a little more well equipped when they come to work. One of the things that we've seen is that be it like softwares or sketching or whatever it is, but just studying in your school and just learning the principles of architecture, when you come and do the real work, it's very different because you're very disconnected. So at least being equipped with something is good because your adaptability is much faster in a real world scenario. So that's something that's good. As far as the softwares goes, I feel that the BIM softwares, also parametric design softwares, it's a little, it's dangerous because if it's not taught well, they just make forms, and because you know what, if you just know the basics of a coding software, even if you input like 10 parameters, something will come up. It'll be bizarre, but something very cool looking might come up. So they feel they can do that. But in reality, it's completely non-doable. So that's something that needs to be curbed. So the educators in this space needs to be practitioners. So that is something that we always keep talking about, because especially in a professional field like architecture, you need to be a doer to actually teach somebody what they're supposed to be doing.
Correct.
Yeah, and that's completely missing. As somebody who does a lot of visiting in different colleges, and I've been taking design as well, especially for masters in digital architecture students, and that's something that we keep doing. And whenever we have a lot of projects, I don't go to schools because it's very important for you to actually practice and then teach. Nowadays it's like, you know, you're just passing out and in a couple of years start teaching, and I don't know what's being taught because the curriculum is dated. Like that's genuinely the truth. The curriculum for a bachelor's degree is extremely dated. It is not relevant. Every 2 years, there's new technology coming up. So I don't think they can keep up, but it's not even a decade old. It's like really old. So if you're not doing, you're not in the field and you're actually not practicing, and if you're going to teach thousands of students, because India is an educational market, I mean, it's insane. So that's detrimental to development. It's a big problem. Like, I can go on and on because it's
No, I
a
know.
big problem.
I mean, you hit the nail on the head. Yeah, we are a education market. I mean, we're producing literally thousands and thousands of engineers in one city, not even the country. And same with architectural schools. So I think we need to make sure, and kind of the responsibility, a little bit of that is on us as well. We need to go back to our colleges and kind of donate time and talk about that. So anything to add on this, or we can
Just from, so I will add from the engineering side of it. So there are 2 points. One, technology side, I don't think so. There are relevant courses still available in engineering. And the second side, if those are available, then mostly theoretical. So there is no industry-based focus or how they're going to apply that into industry, that is lagging. So these 2 things we need to improve if we want to go faster.
I think, go ahead.
I'll just add, just to complement what you were saying, I think there's a very big disconnect between theory and practice. I think it's like 2 different types of thinking, 2 different modes of thinking, and then when you leave college, a lot of students actually face the reality, and that's when the contrast comes out, that that disconnect becomes apparent, because the requirements of the market are sometimes very different from the theories that you are taught in college. Now, whether that's a good thing or a bad thing, that's another debate, but I really feel that as architects, the government, the system should just encourage the best and the best of the talent to go back to the universities and give it back to the students. Yeah. These are young, impressionable students. We really need to incentivize, make it as important as possible for these people to go back. We need to ensure that the best architects are teaching the students.
Yep.
And not just giving it back, it's also preparing them for what's to come. And it's a circular loop. Yeah. And we need to ensure that happens. It happens in a lot of the other countries, and I don't see why that cannot happen over here. And I think commercial benefits are fine, but I think there is a important need for the overall social benefit as well.
Absolutely.
And ensuring that the students get the best.
Agreed. I guess one thing I'll point about students or people right out of school, I made this point earlier today. We're kind of talking about technology and how it's kind of making all these changes. People in our office who are less than 25 years old, second, third, they are so excited, and they want to do all these different tools, and they're really good at it. And I would say at least 80% of them, they're not just doing it just for the sake of doing it. They understand the engineering behind it. And I think that also has to do, I should also say that, because when we are selecting engineers, out of like 60, 70 interviews we do, there's like 2 or 3 which are really understand. So we kind of already taken that out. But a lot of students don't actually understand the basics because they don't get that part of it. How are we doing on time? You're okay? All right, so then one other thing I want to kind of get into is what's next? I mean, what do you guys think is the next disruptor? We've talked a lot about BIM, and I mean, we all know it's not that, and it's kind of Revit-centric or BIM-centric thinking that we have kind of all in that phase, and somehow connected, maybe connected models, this, that. But do you think that's going to continue, or something else is going to come up? I mean, when I asked this question, I'm thinking about kind of Facebook, right? I mean, 10 years ago, it was like Facebook is going to be there forever, and now only old folks are using Facebook. The next thing already is here. So what do you guys think is the next thing and that we should be thinking about, or is there anything like that you see on the horizon that is a good thing? Anybody can take.
I think the obvious answer, I mean, the first thing that comes to mind is AI.
Yeah.
And I think
And what have you been seeing in AI, and what do you think, where do we are?
Actually, pretty scary stuff, to be
Yeah,
honest.
exactly.
Yeah, yeah, it's fun.
It's
to be
fun,
honest, yeah.
fun for architects, but if the owners are actually taking that information and running with it, then I'm not sure it's that much fun or not.
That's true, but I think it's taken out. No, I think it's taken out the seriousness out of architecture, which is fun for me. I mean, you know, architects have this. Architects, engineers, everybody who's a professional take themselves so seriously, and you know, somebody is like just writing a couple of commands is like generating something that's utter bullshit. I'm sure that it's not going to be built. But the fact that something can come out of nothing just in front of you, it's exciting. It's not going to go anywhere pretty much soon. It's going to take a while, but it's
Absolutely.
scary and interesting. It's fun for
Yeah.
concepts. It's exciting actually.
Yeah, we need to figure out how to use that. Right. Yeah, so Siddharth, you're saying?
No, what I was saying is that the reason why I said it's a little scary is the outcomes, the outputs that are in the prompts that I saw. You could see that the whole complexity that goes behind, you know, I mean, it generates a really nice, beautiful looking image. But
Right.
what it does not tell you is the hard work and the effort and the thought process, the human element that goes behind to come at that. I fear for the day when, you know, people who've got little knowledge about some of the fields will start showing those images and start masquerading themselves as designers or engineers. That's a genuine fear, but I guess time's going to tell. But I guess what the whole image of the AI sort of misses out is that background thoroughness, the years of training, education, problem solving, that analytical ability that some of us have. Maybe that's going to go too. We don't know that yet, but my response is based on what I've seen so far.
Yeah. So I guess for the benefit of the audience, what Siddharth and SEEJA are talking about, there's a lot of tools out there right now, like TestFit and Hyper AI and all those things, where like ChatGPT, if you give a command that I want to design a hospital that's 3 stories tall, U-shaped, and these many beds, boom, it will kind of do it for you just like that. Are there any good, I mean, I can think of some good things that AI and ML can do. Do you think that there's something there which could be, especially on the engineering side, I see that that AI ML can be beneficial. You guys can.
I mean, just a thought on this, possibly, I'm thinking aloud really here, possibly our whole industry might split into, might fragment a bit. Already I've heard that IKEA can make a building for you, flat
Yep.
pack, and you can buy it. They don't have traditional structural engineers or architects. They have some sort of half-cooked designer, but they could easily have ChatGPT or whatever it's called. They could have AI. So you can, I mean, we have to decide what it is. Our industry is diverse. Our industry is very pragmatic, functional buildings, and it's also architecture, which is a different thing, which is creating something of artistic interest and of cultural significance that will last forever. Whereas a garden shed is not that. And we could fragment so that architects stick on that side, and on the other side of it, Google will have lots of the big IT companies and whatnot, people who are not used to the background of traditional structural engineering or traditional architecture, realize they can design buildings. They know that. I mean, you know, because there's a lot of information on the
Commodities, I mean, they're basically commodities.
and they will. And possibly with some help from traditional, it'll be perfectly safe. They won't cross the boundaries of doing things which are which we as, or which I as, and many architects want to do. Architecture or art by its very definition is something new. You can't call something art if it's been done before. And in fact, architecture, in my understanding, is that. If you design a building and it's the same as a building someone else has designed before, that's not architecture anymore. So, but a garden shed, of course you can.
Yeah.
So I don't know, maybe this fragmentation is already happening. Maybe I hope it doesn't become a sort of elitist thing that we sit on this side and we do art, and you sit on that side and you do garden sheds. But that is a possibility, as machines can, as you say. I'm sure machines within a few years could produce construction drawings for a three-bedroom house, and could produce construction drawings for a small hospital simply by looking up. I mean, what you have to do is, it's not hard. You just look up the designs of previous designs, and you...
Planning, yeah.
So automated plans is something that even we've dabbled into, wherein, you automate a plan with adjacencies, and there's a bedroom, the size is given, the living, because all of these things are very mathematical, so it can be done. But it's also all about mass customization today, right? Like when you talk about IKEA, that's very relevant all of a sudden, because people want to do something, so Fab Labs coming up, people are ready to make their own fabrications, they want to design their own things, but they don't want to go really above budget. So these things are going to crop up in the near future. And also, like, not all architects who are building and who are commercially very successful are that sensitive to the environment they are building in. Like you said, like India is becoming like New York and like Dubai and all of that. So it's very subjective as to what is going to be the future, to answer your question. I'm not sure if it's going to go this way or the other, or maybe like a healthy mix of the two.
Yeah. Right, like I was saying before, there are some good things that AI and ML can do. I mean, like in diagnostics engineering, we've already started seeing that. I mean, you can, in a disaster zone, you can fly a drone, and if the drone has seen millions of images of different kinds of crack, it can tell you that these are the real ones, these are the fake ones. I mean, so there's a lot of good things that can come out of it as well. Like you said, I mean, there's...
a lot of bad things.
Yeah.
You're sounding like there could be a lot of bad things.
So the fragmentation that you talked about. So from an architectural standpoint, yeah, there's some good things, some bad things. So I think we need to kind of see how to use those tools and how to kind of capture that power. And because it's limitless, and that's really good. And it is scary at some point. I mean, talking with my kids and how they're using ChatGPT, I'm like, man, you need to think about it for yourself. I mean, so it is cool. I guess at this point, you want to add something, Kapil?
So AI and ML we have discussed, but two more things. As a disruptor, what I see is 3D printing with robotics.
Sure.
So 3D printing right now have a lot of challenges, limitation, but in terms of height or maybe what kind of raw material we are going to use for the local area. But when they solve out the material issue, which is a cost and availability, and then they add up with the robotics, then that can become a serious disruptor.
Yeah. And so there's types of buildings where it would absolutely make sense to kind of do a 3D building, but there's lots of others where it doesn't make sense. So I think
I think we're very limiting by talking just 3D printing. What we're talking about is autonomous fabrication,
yeah,
autonomous
absolutely.
construction.
Yeah.
And when you think of a robot, you think of a multi-functioning tool that can do all sorts of things like a human can. But that's not possibly the route forward. The most exciting and interesting examples I've seen have been examples of swarms of robots, very simple robots, a robot that can just turn a screw. But the important thing is they're all connected.
Yep.
All these 1,000 robots that can turn a screw are connected on a building site. They can find a way of moving up the building site.
Yep.
And so they can install. I mean, there's a nice example you can find on the internet of University of Stuttgart, where they did stacking, simple robot stacked planks.
Yep.
Okay, and it's the simplest possible robot. It could just turn and move, and yet you get enough of them in there, and it can create this sculpture.
Yeah.
Through a program. So that's a swarm, and those could be bricks. They could be making a house.
Absolutely.
And that changes not just, I mean, beyond that, that changes the nature of construction. It's 24 hours a day, no safety rails needed, no people on site. That's an exciting future. So I think this, we need to get the mobile.
Yeah.
There's a robot sitting on a heavy plinth making something in its size. That's very limiting. I want that guy to be able to go to the top of that tower and put some more bricks up there.
It's already getting there. I mean, there are robots who are mobile, and I mean, we didn't get a chance to talk about wearable devices, but the models that we are talking about, I mean, there are devices available right now. You can wear it, and you can see, okay, the duct needs to go here and things like that, and people have started using that. So I think, I mean, whether we like it or not, I think we are all kind of moving in the construction 4.0, if you will, that side. And as designers, I think we need to kind of up our game as well to kind of start getting there.
Just imagine a situation, 3D printer is printing the members, okay, and the robots are installing it at any height.
Yeah.
100 meters, 200 meters.
Yeah. All right, I guess maybe we can take a question from the audience if anybody's interested to jump into the conversation before we close it out. Looks like no questions from the audience. Any closing thoughts from anybody? All good? All right. Well, thank you very much. Looks like we have ourselves a bright future ahead. We all need to be adapting to change, some more than others, but yeah, we definitely looking forward to the next 5 years, next 10 years, and I think in a few years we're sitting here in a similar panel and we'll be talking about something else and not talking about any BIM or anything like that. Hopefully that day also comes. All right. Thank you, panel.